Okay, so I had a problem solving request this week to do homework 7, problem 2. So this is my version of the problem. And I'm just copying it down real quick. And then I'm switching to the screen where hopefully you all can see the problem that I'm working on. And then there were two different requests, one to find the solutions in the fundamental set and another to actually work through the algebra. So we're just going to do this whole problem start to finish. Whenever we're solving one of these constant coefficient problems, we start with the assumption that y equal e to mx is the solution. So my first derivative is m times e to the mx. My second derivative is m squared e to the mx, and I need up to my third derivative, which is m cubed e to the mx. And then I plug this guess into my ODE in order to start building my auxiliary equation. So I have m cubed e to mx minus 15 m squared e to mx plus 75 m e to mx minus 125 e to mx. And since I have that e to mx term everywhere, I could kind of factor it out to be left with everything that's not e to mx times e to mx, which means that in order to find my fundamental solution set, I'm trying to solve for values m so that this equation in brackets is equal to 0. And on WebWork, the first problem would just be to type in that equation that I just did. WebWork uses r's, I used m, but this is what you would put in, except for replacing m with r. And then to find the roots, we would have to go ahead and factor this equation. I guess I'll go ahead and put my answers in as we go. That way, if anything goes wrong, we'll learn that. Ooh, I'm not good at WebWork. Minus 15r squared plus 75r minus 125. Okay, cool. So that looks right. And then to find my roots, I'm going to try to factor this. I see negative and 125, so that makes me think that this is just a cubic with 5 and a negative to get the minus terms I'm seeing. And we could go ahead and check that that's true. And if you're not good at factoring cubics, don't worry, that's not part of our exam. You can go ahead and just do a cubic equation calculator online if you want. I don't really care. 5 times 25 is that 125 term. Let's see, minus 15m squared plus 75m. Yeah, that's all going to check out. So this is m minus 5 cubed. Which means my root is m equal to 5 if I'm trying to set this equal to 0. So for that second box, you would go ahead and put in the roots. So they're just 5. And then to get the fundamental solution set, we know m equal to 5 gives us e to 5x, And then whenever we have repeated roots, we multiply by x as many times as we have repeats. So x e to 5x would be the next solution if I only had it repeated one additional time or twice in total. And then to get my third, I just multiply by x again to get that x squared e to 5x. And that's going to be my fundamental solution set. Enter answers as a comma separated list. So e to 5x, x e to 5x, ooh, and then x squared e to 5x. And that's looking right. So to the person who asked about the fundamental set of solutions, all you need to do is, once you get that first one, multiply by x until you've got as many repeated roots as you have. So we had 3 repeated 5s, and we have 3 solutions. So I had to multiply up to x squared to get all 3. And then for the last part, we're going to have to solve a system of 3 equations for 3 unknowns, because our general solution is going to be y equal to c1 e to 5x plus c2 x e to 5x plus c3 x squared e to 5x. Every time we have that fundamental solution set, our general solution is the sum of those functions multiplied by unknown constants. I'm going to have to take up to second derivative to incorporate all my initial conditions. So let's go ahead and start taking those derivatives. This e to 5x, I just multiply by 5 to take the derivative. But then this x e to 5x, I'm going to have to do a product rule. So taking derivative of x is 1 times e to 5x. Or taking derivative of e to 5x, which is 5 times e to 5x, but keeping the x the same. And then same thing with the third term. I take derivative of x squared gives me 2x, leaving e to 5x the same. Or I multiply by 5, leave x squared as it is because I'm taking the derivative of e to 5x. You could go ahead and continue from here and take derivatives, but I like to group like terms so that I don't have to take as many derivatives. So I have these standalone e to 5x terms. So I combine them. And then I have these x e to 5x terms. Where I'm kind of like multiplying through that 5 times c2 here and that 2 times c3. And then I'm just left with that x squared term, 5c3 x squared e to 5x. So now I need to take another derivative, y prime, but they're going to be exactly the functions that I found when I took my first set of derivatives. Just now the thing out front has changed. So instead of keeping my c1 here, I'm going to keep this whole term when I take my e to 5x derivative. So I'm going to have 5 times the constant, e to 5x. And then now, instead of only having c2 as the constant, it's this whole jumble of coefficients. So I'm just going to leave those out front. And then my x e to 5x derivative before was e to 5x plus 5x e to 5x. And I'm going to go ahead and continue on the next line. I thought I'd be able to make room, but I was wrong. Then my 5c3 and take my x squared derivative again. So that was this term right there. So I'm going to have again a 2x e to 5x plus 5x squared e to 5x. And that was the second derivative. So again, I want to combine those like terms. So I've got my e to 5x here and here with no x. So I'm going to have, from the first term, just distributing my 5 in, I've got 25c1 plus 5c2. And then from the second right here, I've got that plus 5c2 plus 2c3 e to 5x. And then for my x e to 5x term, it appears here and here. So I'm going to go ahead and distribute through. I've got this 5 times the constant I had out front before. So that's going to give me 25c2 plus 10c3. And then over here I just have to multiply this 5 and 2 together. So that's going to just give me plus 10c3 again. All that's times x e to 5x. And then my x squared term, I just have 5 times 5. I'm actually going to leave it on the same line, I have room, is 25c3 x squared e to 5x. And then I know I'm going to be solving systems of algebraic equations, so I'm going to try to simplify this as much as possible before I move on. For the first 25c1, but then I can combine those two c2s to 10c2 plus 2c3 e to 5x. And then my 25c2 stays, but I can combine those two 10s into 20c3 x e to 5x plus 25c3 x cubed e to 5x. So that's all my derivatives that I needed. And I need to incorporate my initial conditions. So I'm going to have to copy these over to the next page, which is just going to take me a second. I wonder if I could like grab all of this and all of this. Nope, okay, it's not going to like that. That's okay. We'll at least take the one I got. Okay. So that was my y double prime. Oops. Sorry, my y prime was that one. And my y I hadn't grabbed, but it was c1 e to 5x plus c2 x e to 5x plus c3 x squared. Squared e to 5x. And then my y double prime, I'm going to go copy paste. Oh, I didn't switch pages there. Copy paste this thing real quick for us. If I can get it. Let's see. Cool. All right, and then I just have to combine that with the initial conditions I was given, minus 1 for y of 0, minus 7 for y prime of 0, and minus 43 for y double prime of 0. So I just wrote those down real quick. So I've got y of 0 is going to be c1 e to 0 plus c2 times 0 e to 0 plus c3 0 squared e to 0. E to 0 is 1, so that's just c1 plus the rest, except for I multiply by 0 in the x and x squared terms. So I'm actually just left with c1, and those two go away. And we're actually going to have that our x and x squared terms go away from all these equations for that reason. So y of 0 is just going to be c1, which is equal to minus 1. Then y prime of 0 is going to be only this term stays. The others multiply by x, which is multiplying by 0, so it goes away. So I've got 5c1 plus c2 times e to 0, which is just 1. And that's minus 7. I guess I'll write the whole thing because I have room. And then my y double prime of 0 is going to be, again, only our first term, 25c1 plus 10c2 plus 2c3 e to 0, which is just going to be the constants, 25c1 plus 10c2 plus 2c3, and that's equal to minus 43. So I'm just solving these three equations for three unknowns. I've got c1 is equal to minus 1. So then my second equation, 5c1 plus c2, becomes minus 5 plus c2 is equal to minus 7. So that means that C2 is minus 2. And then I can put both of those into the third equation. 25C1 plus 10C2 plus 2C3 becomes minus 25, plugging in minus 1 for C1, minus 20, plugging in negative 2 for C2, plus 2C3, and that's supposed to be equal to minus 43. So I've got minus 45 plus 2C3 is equal to minus 43. That means that C3 is equal to just 1. Yeah. So those are my 3 constants. And so my final answer, this y equal to C1 e to 5x, C2x e to 5x, C3x squared e to 5x, I just plug in the c's that I found. So I've got minus e to 5x, minus 2x e to 5x, and then just plus 1 times x squared e to 5x. And so I'm going to try plugging that in, make sure none of my algebra went wrong. I've got minus e to 5x, minus 2x e to 5x plus x squared e to 5x. And that's correct. So for the person who asked about doing the algebra for this last part, my recommendation is to make it easy on yourself, take that extra step to group like terms at every derivative. That way you only have to take these product rules like once each time. The thing to be careful about is sometimes I've been seeing people say, well, I know that these multiply by x, so they're going to go away when I plug in 0, so they just ignore it the whole time, which ends up not working out because you see the C2 creates an e to 5x term for us, and then this 2x right here becomes the C3 we see, which again creates a term that has no multiplying by x as we move forward. So you'll lose information about those coefficients if you ignore the x and x squared terms. Otherwise, I haven't seen a lot of other stuff go wrong here. Just if you don't clean up your derivatives in these steps, it can make the algebra really easy to mess up. Whereas if you keep everything kind of grouped up nice, the final equations you solve are quite easy. So that's my recommendation here. Thank you all for asking questions about this, and I hope it's helpful for finishing your homework.